So my name is Brian Niskowski. I work for a company here in San Francisco called Cruise Automation. You may have seen me earlier stumble onto the stage for approximately 1 minute and 50 seconds and ramble off a few sentences. So hopefully now I have more time to elaborate on some of the bullet points I was talking about. I've tried my best to really encapsulate the 3 themes into the presentation. I really tried my best to keep each theme bundled together, but unfortunately, there may be some bleed over where we're discussing one type of topic and it doesn't connect, so I apologize in advance, but I'm really gonna try my best to weave them all together and make it, give a bigger picture. And those three themes are like a philosophical discussion, briefly. So philosophy is not your thing, I'm sorry, but we're gonna go deep into some nuances of security and life, et cetera. Then we're going to talk about some scaling topics, and not so much scaling from a technical perspective, because luckily for me, someone else this afternoon is going to cover scaling Vault. So I got off easy. I don't have to go into all like, oh, here's how you do your N whatever clusters. I believe it's right after this presentation. So when I'm done, you can go to the next Vault. If you're on the Vault train today, you can continue to hop aboard. And I believe it's the next session. So, and those are like the expert guys, so you can probably trust them more than me. And lastly, we'll kind of go over some cool things that I think we're potentially working on, and you may not find them so cool. Disclaimer. A second disclaimer is that this is not a one-size-all situation. This is more of a thought exercise of, hey, I like how we thought of this one particular component. It's not gonna work for me, and it probably won't. So just kind of keep that perspective that some of the things you hear me say may or may not be applicable to you, but maybe just try to like inspect each component of it to say, okay, this could potentially be used in my organization. That's my only goal. If you could walk away with one small thing, I'd like you to walk away with maybe 2 or 3 things that would be beneficial, but if it's one small thing, that's kind of my real goal here. So first we'll get into the philosophy component and what I call the dishwasher philosophy. So who here has a dishwasher at their home? Do I have to explain what this is? Look, it's a thing. So it's a cube. You put dirty dishes in, water sprays, and your dishes come out clean. So who here has an office dishwasher? That's an absolute disaster. So like, you'd think it'd be really easy. You go throw a bowl in, the magic machine cleans it, and it's not. So the problem is that oftentimes it's a very simple concept, but it turns out being executed poorly in environments where A, it's not maybe well understood, or complicated, or rushed, et cetera. So you can kind of draw those parallels to kind of building your own Vault environment. If you're not thoughtful and considerate, and think of the external factors of the things you need to do, it can just turn out like, the security initiative of Vault can kind of turn out poorly. So execution and planning is kind of everything. So if you come to this talk today to say, you know what, I'm really gonna deploy this Vault cluster, Brian's gonna give me all the answers and I'll have to think about it once. It'll be like the Showtime rotisserie barbecue, I'll set it and forget it, and I'm gonna be gone about my way and reach my compliance checkbox. That's not gonna be the case. So trying to get you to think about how will we do things thoughtfully, how will we do things flexible, and things that can potentially scale with changes in the future. Because I don't know about you, the business I'm in, things change often. So if we go with the one big solution X, and we've invested a lot of time into it, and don't think about how not to be very, like, maybe we're not very flexible and very rigid, then surprise, 2 months later when the next person comes in with a better idea, we're not very, we can't adapt to it well and deliver a good security solution. So as luck would have it, our problem sets are pretty similar. Who here is responsible for running some type of application that runs on a computer? Good, so are we. The application in this case happens to be a car with some computers in it. That's kind of at its simplest element. But really, they're kind of the same thing. And I'm not here to tell you that we've been tucked away in a lab somewhere developing some new cryptographic primitives. Like we're going to release something better than some key size with this type of cryptography. We didn't do that. What we want to do is leverage things that were flexible, that adopt kind of industry best standard primitives and put them in the environment because we want to deliver solutions as quick as possible, right? If, for example, there's a group of developers who need to deliver something and we need to have a security component involved, we want to be able to deliver that solution quickly and not be a roadblock and not be kind of complex and the typical, oh, you cannot do that because we have to follow X, Y, Z. So what are our security objectives from securing autonomous vehicle? Well, it's not just we got to think about the vehicle, we got to think about the whole picture. By itself, the vehicle goes and it's secure, and that's a good thing, that's a good feeling, but there's all these peripheral systems that are around it that interact with it, and those are kind of key too. So it's kind of looking at the whole picture. right? How do we secure the vehicle? How do we secure all the components that are just as important that connect to the vehicle and make this thing go? It's like we want a healthy, secure ecosystem. So our primary security objectives are to introduce minimal friction. So if we come up with a new process or implementation, it needs to be implemented as smooth as possible, with as little friction as possible. Because most security organizations don't have the best reputation, so we're trying to improve that by delivering them easy to use, nice solution. So obviously the other two bullet points are the information security industry de facto. We want to trust and protect all the data, which we want to do. We want to trust who the data is coming from, that we can go through some type of process to vouch for the thing trying to do whatever it's trying to doing, and we want to protect it so no one else can see it. We also want to be successful. That's our goal as a security organization, is to achieve the objective. So 1 and 4 are pretty important right now, but the last one, which I've bolded for you to add some extra emphasis on, is be ready to build. And that means that you have this one tool, Vault, be ready to identify gaps in the system and be ready to develop tools for those. So maybe if you're not a software engineer by training, but you've always liked to be, or you have someone on your team who wants to shine in that component, you should really leverage that and be ready to identify pieces that aren't there and build those pieces. Whether or not that someone announces them on stage today or tomorrow, you should probably be ready to build that, plug it in so you don't hold up the rest of the org. If that's like the #1 piece of advice I could give, that's what it'd be. So how we've done stuff in the past is, let's do the example of, I have this file that exists in a code repository, and we have these standard complexities and primitives, that like a cryptographic operation. And typically, up until now, if you haven't implemented Vault, you've had these miscellaneous tools, like maybe you like to use OpenSSL command line to encrypt files. Maybe you like to use some Python wrapper. The point is, there's all these tools that are inconsistent. So team A encrypts with GPG, team B doesn't. So when you need to share a file, like you're gonna have to go to like Stack Overflow and look it up. And you can be honest, like you don't remember the flags to import a key and do all this stuff. So it's kind of a not very fun experience. So, and you don't want to admit it either, right? That's like the #1 thing security people, maybe other people don't want to admit, is I just don't quite understand that thing because I didn't spend the most time with it. So the second step you should take is just admit it. Like, this is not my expertise. Like, who here has a PhD in math? Me either. Good. We're among friends. So guess what? I'm not going to be able to solve these complicated equations. So just own up to it. There's a ton of really smart, thoughtful, hardworking, well-educated people solving these problems for us, providing these extractions so that we can leverage them. And in this case, we have like, the standard cryptographic primitives, and we have some abstractions on top. Then what Vault gives us is an HTTP API. I'm pretty sure that most people here can use an HTTP library, or at least figure it out. That's like a common language, right? Well, math was the common language before. It was a pretty difficult language to learn, so we move up the stack a few pieces. So now we're talking HTTP, a language that we can both understand. So this immediately makes our environment much easier. Now, if we were to implement a security tool, that would be, let's say, some confusing binary protocol that is not easy to read and understand and well known, the security tool you implement might not be as successful. So think about that. Another thing that's really important to do, so our organization, if I were to put like, the growth, it'd be the standard line, linear. Everyone has a linear growth line. It's like the typical thing. Our organization grows. And as it grows, initially, if you're lucky enough, like me, to kind of incorporate these security philosophies from the bat, you can kind of set the expectations for in this case, authentication. Like, how often should a user authenticate? Like an end user and engineer. Come up with realistic expectations, maybe like 22 hours, maybe once a day. Maybe that's not acceptable to an org. But the problem is, you're dealing with several humans, and you have to negotiate this social contract of, I want the development team working on product X to authenticate every 14 hours to prove they are who they are, to access these secrets. It's a little bit harder to sell than, well, I have a robot that expires every 2 hours. I can just develop software that A, makes it inspect its token, and B, renew it automatically. So robots are the easy part about this equation. Humans are the hard part. So kind of initially set the expectation of, hey, we're going to adopt Vault and organization to work on this large project. And as part of this project, you need to authenticate on X interval. But then you can, this is where I'm starting to blend those 3 things I talked about earlier. I'm already doing it. I'm only like 9 minutes in. You can leverage that thing that they do, like authenticating to Vault, to get some kind of identity token to prove who they are. You can use that to leverage other things. Spoiler. So now that we've kind of set the expectation to our development group and end user group that you're going to authenticate on a reasonable interval, and you're going to do 2FA and all that good stuff, the standard de facto things, we move on to the onboarding strategy. So as you ride that linear graph of goodness, of feel-good company growth up and to the right, you have the problem of getting people onboarded to Vault as well. So it's as simple as just use it. And people come up to you with the sentence that says, I want to store a secret. Great. You have to have a good answer for that. And do you? Like, oh yeah, just use Vault. And they'll go look at this wiki page and maybe may or may not be very beneficial to them. They'll become disgruntled and say, you know what, maybe I'm not going to use Vault. I'm going to go back to this OpenSSL command line because it's easy for me to remember and I don't have to go through this whole entire new process. So the onboarding strategy is extremely important. So I've developed these 4 onboarding questions that you may take and use in your organization, and do not give credit to them to me. So someone comes to you and says, hey, I'd like to use Vault. So identify the data type they want to store. So is it as simple as I need to store some string, I need to retrieve it later, or kind of dig deeper in the weeds, or hey, I'm going to do this again. I'm about to bleed over to another topic, but hey, I have this signing operation that takes place using this proprietary type thing. It's kind of a standard, but kind of not, and we want to implement this into Vault. So gather that information first. Next, identify who's going to administratively manage this data. That's always the important thing. People always mostly think about who's going to consume it, but it's also important to identify who's going to manage the data. So from day one, you may populate some secrets, and a bunch of users can then use it. If you don't clearly define who owns that, is responsible for maintaining that, and setting up those kind of policy and authentication boundaries from the get-go, you're going to have a little bit of a hard time. So after you've okay, we want to store this string that's called awesome password, the most basic thing you can possibly do. This team X is going to support it. We're cool. Now who's going to have access to this data? Is it going to be a service account? Is it an application? Is it an end user? Because that can then change your question to number 4. Then you identify and implement an adequate authentication method. If it's humans who need access to the data, great. We've already set that expectation that every developer is going to come in and they're going to get, or employee, and get their nice cup of coffee. They're going to read Hacker News for 23 minutes. Then after that, you can authenticate to Vault, get your token. And if that's the case here, cool, you're good. But if it's more complex, like, hey, I have a cloud instance, whether it's either a platform that needs to authenticate, then you need to identify that and set that up. So once you've identified that, if you have a solution for, you deliver it. If not, you go find the solution and you implement it. And luckily, there's a million different authentication providers that have already been built, and you can use those. Those are cool things. Like, people are aware, okay, I got to auth the Vault once a day. Here's the things I can do to get it on board. So another disclaimer, this is not perfect, but it's better. So while this still may be confusing to some people, take this and find another dimension. Maybe number 2 will always be your security org. So don't worry, now it's a 3-step process for you. So you can move on. All right, your adoption is continuing to ride that awesome high curve. And at this point, utilization is through the roof. Everyone's happy. Things are super secure. Now comes the next deep level topic of how do you choose the path structure? How do you choose where secrets are stored? Which team manages the path, the concepts? And some people often come to a security org and they say, tell me what to do. And oftentimes, people don't know. They get back in this case again where they don't know what to do, the fear of admission and guilt, and say, well, do X, even though X may not be the best solution. So maybe it's don't dictate the path, you should encourage it. Well, as maybe a team of developers over here and developers here, what is the best thing you can come up with that can support all of your applications? Instead of me as a security engineer say, you need to use /secret/A/B/C. It's pretty rigid because you don't want to say, hey, I don't really know your workflow, dictate it to me and I'll help implement it. It's been a pretty valuable component, at least in our implementation. Cool, we're almost to the top of the curve now, so let's wait for the crash. There is no crash, sorry. So next is kind of a topic about managing policy and configuration. So let's say you have all these users onboarded, everyone's authenticating, it's all well. In this situation, who here works for an organization where everything is going as well as it is up on stage here? Yeah? Anybody? Well, we're hiring at Cruise Automation, so be sure to visit our website. Anyways, back to the topic. managing policy and configurations, it's pretty important. So what we do from a policy and management perspective, we build out a physical representation in like a file structure type way of what the vault configuration looks like. So I guess if you haven't heard on stage at the keynote, like infrastructure as code is everything. So we thought, well, why would we configure an application like Vault and not use configuration to define what Vault looks like? If we do everything manually and it's not sustainable. So what we did is we wrote a custom app that kind of traverses a tree, a file system tree that's similar to what the Vault API looks like, and you define those values there. So this does two things. One is that it keeps you, obviously, a way to track the changes, and B, it gives security operators a more thorough understanding of the internals and like path lengths in Vault and API, like the schema, basically. So whether if you've used a higher level abstraction command line the whole time with Vault, and you weren't quite sure of the path at which things were stored and retrieved, you can't, like when someone comes to ask you a hard question of, oh, I'm implementing my own Vault client, what's the path to do X, Y, Z? So it's a double positive is that A, you keep track of your config, and B, you become more familiar with the internals. What would Vault be without proper end-to-end testing? So let's say your company is going to go build a bunch of robots that will also talk to Vault. And in the process, like you check some basic health metric, you're good to go. Typically what's going to happen is once the adoption increases on your Vault cluster, it's going to become like a critical path of all these applications. And that begins to worry some people, but mainly the people who have to maintain that cluster. And it kind of makes some people happy, the people who are in charge of compliance and whatnot. Maybe those things crisscross. I'm getting into that problem again. So I highly recommend identifying what are the 4 or 5 common things that your application or your infrastructure is going to do that will contact Vault, and kind of identify a way to do that. So let's say your typical workflow is a read, or to authenticate, write, read, and delete the secret. So what you want to do is you want to build some kind of process or testing framework that exists external to Vault and goes and does this thing all the time. When it's done, it tells you, was it successful in each step? And B, what was the timeline for each of those requests? And this is extremely beneficial for 2 things. One, if there's a trending problem that's starting to occur, you can identify that before someone has to come into your Slack channel and make security look even worse. And B, you can kind of identify usage over time. So like, this team, whether from like a data usage or whatever, so those are 2 things you can do. So next we'll kind of talk about how we deal with policy at scale. So let's say you have a group of application servers. Typically the standard is you have new application A comes online. You write a policy for application A. Application A is spread across 500 servers. They all kind of utilize the same permissions path, and you're good to go. Give them the policy. It kind of checks it as normal. So in this case, like we're spinning up maybe hundreds of robots a day, right? And so what I would be required to do as a security operator is say, okay, I need maybe either build a webhook, or someone puts a ticket in and I'm on vacation and now robot 700 through 2000 doesn't get created, because usually it's this process of like, I have to run my create_policy.py script that generates some number and then goes through and creates all these policies. If you go back to the very first thing of minimal friction, that's kind of like the opposite as maximum. So as these new things roll off the assembly line, these robots, and you're required to then go and do this kind of like manual type thing to scale this policy out, it's not going to work well. Maybe for the first couple hundred, because yeah, like you're really good at knowing when these things come in and you can identify like, hey, we're going to build a new fleet of robots, so I'm going to make vehicle 400 through 500 today, so I'll know. Or sometimes people say, well, I'll offload, and I'll just make all 1 million policies today. But then you have 1 million policy objects to kind of keep track of. Anything could change in those 1 million, and it's a much harder thing to hold on to and kind of analyze. So what we do as Vault Enterprise customers is we kind of use real-time sentinel analysis of a request to kind of minimize one policy. One policy for many things. So before it was a one-to-one in a many type aspect, and now it becomes a one-to-many in reverse order. So now this robot can make a request. Sentinel analyzes that request and says, hey, let me look at some attributes in your request. Does it match up with the request you're trying to make? Cool, all is good, you're good to go. So now where your coworker who wrote create policy.py, it's kind of obsolete because you have this new cool automated thing that takes care of it. Now, are there some problems with this? Most definitely. My tagline is always not perfect, but better. So who wants to create all those policies, then go on vacation and like you didn't create all the policies and you're in trouble? Or you want to be on vacation and be like, oh yeah, I created this awesome Sentinel policy, and now we kind of like, as we scale, I don't have to do anything, and I look awesome. So that's what I'm here to help you do. Another thing we kind of implement is SSH at scale. And what that looks like is there's kind of two ways like the typical SSH paradigm works, whether this is your SSH into a robot or a common fleet of systems that kind of expand and contract. You have this person down here on the computer, which is typically an operator or an administrator, and they need to access any number of systems. And the typical paradigm is like you have a bastion host that kind of funnels the access, and it goes out to X number of hosts in your environment. And typically, a pretty common practice is like, I have a username and password, or I have an SSH key that someone has to disperse to all these 1 million nodes, and I have like a push notification from some two-factor provider. And that's cool and all, but the problem with that is, especially at scale, is so as users are added and removed, you have to go manage all that external data in all this host of clusters. Even say if it's a virtual machine or even like a robot out in the world. Let's say we're not building a driving car, we're building like a drone or something like that. And now you're telling me that every time I have to change access to that, I have to like bring the fleet in and update someone's public key. It's totally not sustainable. So a little more sustainable model is what I call like the SSH Easy Pass. Anyone who's ever been to Cedar Point, which is the world's greatest amusement park, kind of on the East Coast, the concept of the Easy Pass is like you pay a little bit of extra and you can kind of cut in front of everybody. Kind of similar here, but you pay extra from the perspective of you've invested the users into adopting this Vault workflow, and now in the morning, when they authenticate, which they're used to, they have this token that can let them do things like SSH now. So they have these built-in security primitives, and they don't even know it because this one thing happened early on. So it's kind of keep thinking about how to tie those things together. And luckily, I don't have to dig into this further because there is a SSH at scale talk maybe tomorrow. So I would save the gins. I really don't have to cover that anymore. So if you're interested in SSH at scale with Vault, you should definitely go to the other talk and not listen to me. They'll be much more insightful than that last slide. Some other cool things are certificate issuance. So for example, the old days, I guess there's two ways to think of certificate issuance. There's the way in which you use a public certificate authority, and who here has the one person who's like the cert person? Like, oh, I need a cert for this new thing we're spinning up. We got to put a ticket into the cert guy, and now you have to figure out, okay, I don't remember the OpenSSL command to do like the proper certificate request, stuff like that. So you kind of mess around with that. You send it to the cert guy. He gets it back to you whenever. That's cool. Now with the PKI backend, we can either leverage that using a third-party CA and kind of doing some magic with ours. That's expensive. Or you can also build your own certificate authority, which maybe you've been afraid to do so before, and now you can kind of implement this. So this is beneficial for both humans and robots. For robots, again, it's easy, and humans, it's also easy, but maybe not as easy. So from the robot perspective, or the system perspective, we've already authenticated to Vault. We have this token, and all we have to do is make a request that says, give me a certificate. We've already had that trust chain implemented, and a certificate is issued. Same with the user. You know what? Don't worry about the OpenSSL ret command. You don't need to worry about that. Here, make this simple API call, and now you can have a certificate. You don't even have to make the CSR. Just say, give me the name, and I'll give you something back. So again, we're going back to the minimal friction. It's a bonus that it works for people, but it's great that it works for robots, because then you don't have to worry about having to do all this manual work on a robot as well. Another important thing that we implement is Cryptography as a Service. Armand talked about the transit backend today, which is extremely useful. So basically, you all have it now. There are several like private keys lingering in some repository, and you're going to change them one day. I know you will. And what happens is you check those out, and maybe they're password protected, and their password is probably stored in like a password manager, and like they get the password of the password manager, and they run the command line, they decrypt it, they do their thing, and that's kind of like the business as usual. So what you can, I'm not here to tell you all about the transit backend. I'm here to tell you about, think of the things you can do to make that transition process easier. You've identified all these keys in your environment that maybe these systems and people have implemented right now. And step one is, hey, maybe I'll just use those existing keys for a while, but bring them into the environment. So get ready to build. So you probably have to build a tool to do that. So it's kind of an interesting, as a phase one, a compromise. Rather than say, we scan the repo and all the we want all the keys gone. We want them all gone now. That's typically not a sustainable thing, and it probably gives you a bad reputation. So we say, all right, as a piece brokering of a phase one, we'll take all the existing keys and we'll move them into this new abstract primitive store. Okay, and they start to use it and become comfortable. Then maybe a few weeks later, when they're having such a nice time and such a nice experience using Vault, say, all right, now we're going to switch the keys, and it's not so difficult because those kind of basic primitives are implemented. So think about things like that. If from the get-go, the gut feeling, it may not feel like the best to use the old key, but in the long run, it's going to be the most impactful. Kind of a philosophical, I'm crossing the themes again, sorry about that. So now that we've been successful, we have this robot car riding around the street, we have all these platforms, we have all these applications, and as time has gone on and we ride that curve, we're connecting them all together, and we realize that we are slowly becoming the global trust broker, whether you realized it or not. So right now, we integrate, you or I or anybody else in the room may integrate platform provider A, B, or C with Vault, application A is with Vault, and now this other thing, which is a robot that's rolling around several cities, has now integrated with Vault. So now you can leverage that platform to share information, which you couldn't before. And maybe on your radar was, I need to build a strategy to let all these applications authenticate and authorize to each other. Again, you have this primitive you should already be advertising across the business to use, and now you can use that. So now I need to get, now my cloud provider A needs a secret for cloud provider B because we haven't migrated that data over. Well, guess what? In the past, you'd have to generate some keys, copy them over, or copy them into something, some really hard process. And now we can just leverage the existing identity provider we have. In this case, is up one level with Vault, and say, okay, cool, you give me that instead. I don't worry about it. So now you are a global authentication broker, which is scary. From a perspective, it's kind of like all your eggs in one basket. Not perfect, but better. In addition, you can do things like cross-service talks. This is what we, kind of a way we use to solve a problem of, okay, we have this rolling computer, and we need to talk to multiple services, and these multiple services are also using Vault. A little redundant from the last slide, but hey, it kind of, it clicked that, hey, there's always been this policy and stuff around how this service A authenticates to this kind of central place, and now this new thing does. Why don't we leverage that, build a few little complexities on top of it. Now we have this integrated crosstalk that's both secure and manageable. So I guess at the basic form, authentication is a form of like, I give you a piece of information and like you match a string. You compare and contrast. If equal, then authenticated. So typically in the real world, this is easy for cloud provider A. We use their underlying identity management store, and we leverage them and say, hey, X is this. Can you prove it's that? And typically, we're going to trust them to make that decision and give us back the result. We can do the same. We can do the same thing with cloud provider A, cloud provider B, LDAP, et cetera. So now we had to think, we have this thing rolling around. It's a robot. So how do we authenticate it? Kind of the same way. You can take these basic primitives about it and ways to improve it. And what we did, we wrote a Vault plugin. Basically the last 10 slides of this will be totally dedicated to me talking about how awesome Vault plugins are. It's like, write a plugin for it. And so if you have any plugin writers in here, any plugin authors for Vault, yeah. So if you haven't, I recommend go checking it out because it's really, really cool. So in this case, we have all this information, maybe in random places about a robot. We can kind of categorize that together, use other basic security primitives. Hope you see the theme here is that we pick things that have been proven and trusted, and we leverage those to implement the most basic workflow. We're not here to write a new encryption standard. We're here to use things that exist, implement it, make the workflow easy, frictionless. So that's how we kind of authenticate new and custom things. So I have 2.5 minutes left. I'll kind of go through some cool things that we're working on as like our labs type projects. And the first one was codename Indy. So it's kind of like a Vault client, but for servers. So we saw this problem that people had applications or servers, and they needed to authenticate to Vault. Well, typically the user experience is you have this command line client you download. You have to do some configuration. It's a little bit different, but that's not a great experience for a robot. So we said, what would a robot like to do to authenticate? And what the robot like to do is you just run this binary, identify all these custom attributes automatically, and authenticate it. So we worked on this project. It's basically, it does just that. You give this small binary to a computer, and it can authenticate a vault without having to worry about, where do I download the vault client from? Or is it trusted? Do I have to have this whole extra process? So as a security engineer, something as simple as you need to download a binary to authenticate to the system becomes difficult because all these extra 50 questions come. Like, I got to download it. It comes over the internet. Now I have to teach end users the workflow to validate the binary. If you already have an existing framework to do that, you can build this small application like we did, but it's like a client for servers. And you may say, but Brian, Vault just released this. And yeah, that's the risk we take. And sometimes we know something better may come along, but there's a gap. We identify it, we build it, we move on. And if something better comes along, we have no problems with scrapping it and replacing it. Another cool thing we just started working on is Terraform Enterprise Auth. And at the kind of the lowest level, the old workflow was you have these people with their laptops that have already done this awesome Vault workflow. Everyone's got a token. They leverage that token to decrypt stuff and send it to the cloud. Well, if you're moving to Terraform Enterprise, what are you going to do? Have people copy and paste their keys into some job and have to worry about. So it's kind of like you had this great security solution. I guess the point I'm trying to make is you can develop a solution that works well. You add an enhancement that can kind of change the structure of that. And now you have to rethink that. So kind of be prepared to do so. So the theme of I'm going to install Vault and I'm going to store all the secrets and we're going to be awesome forever and I can maybe work like 5 hours a week, that's totally not a thing. So there's a plugin for that. As I said, my common theme is really identify. So we have an application that has all these subtasks, and those tasks are different and need separate sets of secrets. So what we do is identify each task. Is there a way for Vault to talk back to that service and trust who it is? Again, we write the plugin, we delegate the trust to someone else, we trust them, and we issue the token. So with 0 minutes left, just to kind of review the bullet points, our success story with implementation is introduce minimal friction, trust, protect, be successful, and most importantly, be ready to build these custom solutions to make people happy and secure at the same time. Thank you.